there exists a small sparse subnetwork which yields a similar evaluation metric as the main network. So what means by this statement is, if you take a very big neural network, we can find a subsparse small neural network from the from the very big one, the neural network. That is, this small sparse network yields a greater than or equal to any evaluation metric which the teacher model, which the main model yields. That is, here evaluation metric is, it may be recall, it may be on precision, it may be on accuracy, sensitivity, etc., what we actually decide. So you might think, what is the basic difference between the normal pruning and pruning via lottery ticket hypothesis? So say that I have a model and I train a data set where it reaches around 90% accuracy. So to reach that 90% accuracy, I have to prune the model. Say that I prune for a total of 100 epochs, I prune every 10 epochs. So now what the normal pruning does is that after I prune in the 10th epoch, it will reinitialize the same weights which has been contained in the 9th epoch. So in a similar way, after I prune in the 20th epoch, it will reinitialize all the weights which is contained in the 19th epoch. So in a similar way, for 30th epoch, 40th epoch, etc., it will be going on. But here in lottery ticket hypothesis, this random reinitialization is a major part. That is, if I prune in the 10th epoch, it will reinitialize the weights from the first epoch. So if I prune in the 20th epoch, it will again reinitialize the weights in the first epoch. So that is, random reinitialization is one of the major criteria of lottery ticket hypothesis, and through this lottery ticket hypothesis we can find a very small neural network which actually performs really well than the bigger neural network. So this is what lottery ticket hypothesis is. And talking about knowledge distillation, there is a teacher model, there is a student model. So as the name suggests, the student model will be learning and it will be trained from the distilled knowledge from the teacher. So with this basic knowledge, we will actually dive into my main methodology part. So here in this photo which you can see, the input is a image matrix or a embedding vector matrix. So the input is first being passed to, simultaneously it is passed to a pre-trained teacher model and a student model. So now the features of the input from each layer of the teacher model is being taken, and the features from each layer of the student model is being taken. So here I am trying to explain what is happening in one epoch, that is first forward propagation and then about the backward propagation. So what is happening? So after the features are actually taken from each layer of both the teacher and the student model, now the features from each layer of the teacher model will transfer its features to a suitable layer of the student model through this concept called as attention mechanism. That is, it will see how similar the features are and then it will transfer to whichever layer it is highly suitable to transfer, and it will transfer the features. So from there, back propagation takes place. So during the back propagation, we try to prune our model. So we prune our student model during the training process. So through this pruning stage, we developed 3 new models. One is SPSAD, which stands for structured pruning with show, attend, and on the distill. Second is LTH-SAD, which stands for lottery ticket hypothesis with show, attend, and on the distill. Third is SS-SAD, which stands for sparse student with show, attend, and on the distill. So what happens in structured pruning with show, attend, and on the distill, that is SPSAD, is that while we are training, normal pruning takes place. That is, as I had explained you on the difference between LTH and normal pruning. So here normal pruning takes place during the training. And then what happens in lottery ticket hypothesis with show, attend, and the distill, that is LTH-SAD, is that the same pruning takes place, but here the pruning is done using lottery ticket hypothesis. And third, sparse student, SSAD, what happens? Here the pruning does not take place during the training process. Instead, the teacher model is taken as the first step of lottery ticket hypothesis, and as I told you, the end product of lottery ticket hypothesis would be a very small student network. So after the lottery ticket hypothesis is done, so after the lottery ticket hypothesis is done to the teacher model, we will get a end product with that is a smaller student model. A smaller model. So that smaller model will be acting as a student model in the knowledge distillation process, and the training takes place. So this is the major difference between the three models which we have created. Then we will talk about the data set used. So case 1 is image classification and object in the detection. Case 2 is recommendation system. So for case 1 we have used CFAR100 and CFAR10 dataset, and for case 2 we have used movies dataset and Amazon dataset. So the details of the dataset are being shown here. So then when we applied CFAR100 dataset to our model, basically and gratifyingly, that my model LTH SAD yielded 73.03% accuracy with 60% of the model size pruned. And when we applied that into SS SAD, yields around 73.71% of accuracy by reducing 70% of my model size. That is, retaining 30% of the model's parameter, we are able to achieve 73.71% of accuracy. And similarly for CFAR10, our LTH SAD yielded 93.02 with just 55% of the model size pruned. That is, retaining around 45% of the model's parameter. And then for the case 2, when we applied on the movies dataset is actually basically classified into 4 different features. One is categorical features, numerical features, textual features, and social features. So interpreting these tables, LTH SAD was doing really well from social features and then the textual features. And in these 3 datasets which we just discussed, it didn't explicitly beat all the baselines. So there was a trade-off between, the best part is the trade-off between our model's accuracy and the model size. But here in Amazon dataset, our LTH SAD beats all the baselines with having 65% of the model size pruned. That is only retaining 35% of the model's parameter. So we achieved 1.9988 MSE and 1.047 MAE in Amazon dataset. So this talks till this stage, it talks about the so talking about the scalability part, we have used 3 metrics. One is GPU power consumption, second is throughput, and third is AQRT. So first, talking about GPU power consumption, here what we mean by GPU power consumption is it captures the power consumed by our model during the training phase as well as during the testing phase. So we achieved 44.31% less power with 60% of the reduced size model using CFAR100 dataset. So for CFAR10 dataset, we have achieved 37.62% less power with 55% of the reduced model size and 66% less power consumption with 55% reduced model size using movies dataset, and finally 25% less power with 65% reduced model size using our Amazon dataset. So this was the first case. Second and third case is we tried to mimic a real-time scenario of Spotify or even the Amazon e-commerce website. So there, what we tried, we put a constraint on our RAM size. That is, instead of having a very big GPU machine, we used a Docker to constrain our RAM to 2 GB size. And then, so the throughput here talks about how much time it takes for our model to, basically throughput talks about the time taken by our model to predict one output, and AQRT stands for average query response time. What it states that how much time our model takes to recommend top K products. Say that if you are using Spotify, or say that you are using Amazon, so when you enter that, the Amazon site will actually recommend you top 5 products. So AQRT tells exactly that. So here for us, I mean, we have taken K as 5. So if you just see the graph here, interpreting these graph, if you see the pink line in the top graph represent, that is the lowest line in the top graph, which yields very less time, and the bottommost line in the second graph, which is in green color, represent our model. So both the graph, the top one is for AQRT and the bottom one is for the throughput. So our model this shows that our model is very scalable. This is because of lottery ticket hypothesis, which prunes the model by removing very less significant unwanted neurons and the connections used. So some of the managerial implications are the visual search, personalization, cross-domain recommendation, etc. And our work got accepted in WITS, that is workshop on information technology and systems, and we have also submitted it to machine learning journal, and I hope it would be accepted in that also. So yeah, so this is about my seminar, and thank you and have a nice day. Please do subscribe to my channel if you haven't subscribed yet. Thank you.
User search, user effect, use state.